Well, good morning, all of you that are still left here. This looks like the survivors of the group, so either this is not the drinking crowd or you guys have a higher pain tolerance. So anyway, congratulations for being here. So a little bit about me first. If I haven't met you before, my name is Steve Discher. I'm from College Station, Texas, same place as Greg Soul, and happy to be here in Miami. I'm a MikroTik certified trainer, have been since 2008, and I continue to teach Router OS classes. My website is learnmikrotik.com. I blog at stevedischer.com. And I operate a wireless distribution company called ISP Supplies, also located in Texas. First thing I want to do is congratulate 13 new MTCNAs. We came in here on Sunday. There's one right there. And came in on Sunday, worked Monday, Tuesday, and Wednesday. So if any of those guys are in the room, would you just stand real quick? I know you hate doing that, but I want to recognize you. All right, good job. All right, so everybody is here, and you likely registered through the MUM, through the web page. And when you registered, you entered your name, your contact information, and you were probably given a choice whether or not you wanted to give a presentation here at the MUM. And so I did that, as I have for the last 5-6 years, because face it, I like to hear myself talk. So I went ahead and registered for a presentation. That's going to get annoying if that keeps doing that. Maybe I need to just leave the cable alone. Come on, baby. Sergey, I maybe should have borrowed your adapter after all. Is he still here, Sergey? Ah, frustrating.
Where you need the A+ guy.
Exactly. Hey, guy with the A+ certification, come show me how to make a cable work. Wow, that was uncomfortable for a while. All right, I got it, man. I just won't touch it anymore. All right, so back to my story. When you registered for the MUM, you were given an opportunity to make a presentation. And so I marked down, fine, I'll give a presentation. So it wanted to know what the title of my presentation was going to be. Well, like most presenters, I wait until the last minute to write the thing, so I didn't know. So I put something that I thought was clever and kind of funny. Apparently, it did not translate well, because they didn't think it was funny. So what I got was case study. So word to the wise, if you don't put something specific, you too will get a case study. So I've had people coming up to me all week going, so what did you do? Did you study different types of outdoor cases or indoor cases? I'm like, no, in fact, I haven't even written my presentation yet. That's why I got case study. So keep that in mind. What we are going to do is take some presentations from the past, put them all in a bag, shake them up, and see what comes out. So I want to look at 9 different Router OS forgotten features, what I call configuration calamities that get you into trouble, and some sweet solutions to some simple problems. So to do that, we're going to take a little drive down the road less traveled. Time now for Router Board Jeopardy! Your host today is yours truly. So, we have to pick from today the categories of dynamic duos, DNS wars, WTF, and it doesn't mean what you think it does, pull my hair, that's one for Greg, sorry, control your extensions, and who pooted, okay? Am I desperate for a laugh, and will I use potty humor? Absolutely. So let's get started. Which category would you like to do first? Come on, somebody. How about dynamic duos for 200? All right. So what we're actually going to talk about is inbound NAT with a dynamic IP. So it's pretty simple. You have a dynamic WAN IP assigned to you by your DHCP server or your upstream ISP's DHCP server, but you want to allow inbound services, things like maybe you have a mail server or a web server. So there's really 2 pieces to this, and we'll talk about the second piece momentarily. You'll have to guess what that category is. But the 2 pieces to it are, first of all, how do I write a destination NAT rule when I don't know what my IP address is? So here's a scenario Oh, I've got a pointer too, so now I'm really deadly. So we have a connection to the internet, we have a public IP that changes all the time, and then we have an RFC 1918 address inside our network for our Windows remote desktop server. So what is normally going to happen with the destination NAT rule is we're going to receive an IP packet with the destination IP that is our public address. And what our router or firewall should do is strip off that destination address and put on the new destination IP, which is our remote desktop server. Well, pretty easy rule to write when we know what our public IP is. We simply say chain destination NAT if the destination address is our public address, and if the protocol is TCP destination port 3389, we're simply going to switch out that IP to the private address. So the rule works, pretty simple. We use these kinds of rules all the time. But if we don't know what that address is, then we potentially have a problem. So that's where the extra tab comes in, and a lot of people tend to ignore this, but on the extra tab is something called address type. What address type can do for us is allow us to use the local setting. The local setting simply means that the address is local to the router. In other words, an address bound to the router itself. So now, without knowing what our public IP is, the rule continues to work because we find traffic in the destination NAT chain with the right destination port, and if that address is an address bound to the router itself, that is, it's a local address, it's going to do the destination NAT to our private IP. Very simple solution to what could be a complex problem. I've seen people write scripts and everything else to make this work when what you need is right there and it's really simple. All right, so back to our board. We're going to do DNS wars for 400, or how to not be a participant in a DNS attack. So by default, RouterOS has a configuration that involves DNS caching or allowing remote request. Simply means that our router will act as a DNS server for our local area network. Fortunately or unfortunately, however you look at it, many of us take off that default configuration, which also includes firewall rules on the outside interface. So if we go back to using allow remote request, but we don't have a firewall rule on the WAN interface, we are now an open DNS server. And Tom talked quite a bit yesterday about what that actually means. So if you don't want to be a participant in a DNS attack, you need to write a firewall rule to specifically block port 53, UDP, and TCP when it comes in from the WAN interface. So simple solution to what could turn out to be a very complex problem for you. Next, we're going to do WTF for 600, which actually stands for where's that firewall, okay? The point being that when you have a dynamic IP and it's changing constantly, you, in the past, only have one choice, and that is to write what could be a problematic DNS or dynamic DNS script to help you find that device when it's somewhere out there on the interweb. Fortunately, starting with RouterOS version 6.14, MikroTik added its own dynamic DNS naming service that they call IP Cloud. And you can find that in Winbox under IP and Cloud. So what this means is using the IP Cloud feature, you don't need dynamic DNS scripts anymore. Those completely go away. All you do is click on IP and Cloud and tell it to enable DDNS. And what it's going to do is to create a DNS name for you at mynetname.net. And it's kind of a cryptic looking thing here, but anyway, you can take that DNS name then, and depending on what you're using for your DNS server, in this case I'm using OpenDNS, but not OpenDNS, what's the PowerDNS? I'll get out in a minute. So all I do then is create a CNAME record in my PowerDNS for, in this case, office.ispsupplies.com, with that as the content, add the record, and now anytime my DNS or my IP address changes, my DNS name keeps up with it. It happens automatically in the background, and I don't have to have any complicated scripts to actually make it work. All right, I did this slideshow last night, but I didn't use the presenter function, and so it's kind of messed up some of my links. So I'm going to go back to mirroring displays here and see if it makes my links work more correctly. There we go. All right, so back to the big board. What would we like to do next? So far we've done our dynamic duos and our DNS wars and WTF. What's next? Pull my hair. All right, pull my hair for 800. So what we're actually talking about is not pulling Greg's long, lustrous locks of hair, but something called the Hairpin NAT. So the situation is very common, and that is that we have a web server or some kind of other server living within the private network here, in this case at 192.168.1.2, and we want to allow service to it from the outside world. So we create a destination NAT rule that makes all of this work like we described previously. So in this first example, a host at the address of 2222 comes into 1111. We destination that to 192.168.1.2, and everything works correctly. So the source IP is here. Here's the original destination IP here, which was the outside of our firewall or router. Okay? So then everything just works correctly because the host that's on the outside of the firewall is accessing something on the inside, and the NAT works as we would expect it to. Where we run into a problem is when another host on the local area network tries to do the same thing. Now, I've seen a number of different approaches to this. One is using a local DNS entry on the local area network for the private IP, and then using a different DNS entry on the outside of the network for the public IP, and that is one solution. But another way to do it is using what's called a Hairpin NAT rule. What the Hairpin NAT rule is going to do is look for any traffic coming from the local area network that is going to this outside address, and then it's going to perform a masquerade on it. So what happens here is that the server replies. In this scenario, the server replies, but the source IP of the request is on the same subnet as the web server. The server doesn't need to send the reply back to the router, but instead sends it directly back to 192.168.1.10 with a source IP and the reply of 192.168.1.2. The client receives a reply packet, but discards it because it expects it to come from 1111. So there it is again. We send the request to 1111, but when the reply comes back to us, it doesn't come from where we expected it to. It comes from 192.168.1.2 because he's on the same local area network as us. So the solution to that is what we call this Hairpin NAT. The Hairpin NAT says I'm going to look at any traffic that's coming from the local area network. And if it's going to the server that we're doing the destination NAT rule to, and if it's TCP, and if it's port 80, and if it goes out interface Ethernet 2, we're going to masquerade it. So basically what happens is that we masquerade traffic from the local area network going to another local area network host, but only if it first goes to our outside IP address. So this is one of those examples that you have to look at it a couple of times, and that's why I put all the steps in there. You can go back and review it and see what the process is, but at the end of the day, you're simply going to write a rule that sources an address of everything from the local area network going to this particular host and then performs a masquerade on it. With this method, we don't need extra DNS entries, and everything works as we would expect it to. All right, and finally, looking for the cheap laugh, who pooted for 1,000? This has got nothing to do with special login, but again, I just wanted a cheap laugh, so here we go. Special login is one of those forgotten features that we don't think much about. And the reason being that it's not something that we typically even understand as being an option for us. But what special login can do for us is allow us to use the serial port of our router and then access another device through that serial port, but do it over TCP. So with special login, and it's found under System Special Login, we can simply add a new user with a port in the special login. So in this case, first we have to disable the serial console so that it's not running on that port. Then we add a new user with a port name in special login. So now what's going to happen is that from our laptop, if we try and SSH to user serial at router 1, our traffic will be redirected through the serial port to router 2. So this is a good scenario to use when you have a router that's accessible via its Ethernet port, but maybe you have a switch in the same rack that you want to have kind of a backup route to get to it through its serial console. Then you can use special login for that particular application. So again, simply SSHing to the router 1, because we're using this special login user, will forward that traffic through the serial to router 2. That's right, it's time for the bonus round. So, the bonus round, UP'd, let it flow, and config me baby. That's our last 3 choices. So we'll start off with, you guessed it, UP'd for 200. Actually, I'm talking about UPnP, which is universal plug and play. Universal plug and play is one of those things that it kind of works, and sometimes it helps, and sometimes it doesn't help that much. And primarily, I think it's due to the way certain products out there view NAT. Particularly, I'm talking about Xbox, which seems to be the most problematic. But universal plug and play is a transparent peer-to-peer network, typically seen in gaming consoles. UPnP is found under the IP UPnP menu in Winbox, and the configuration is pretty straightforward. First of all, you have to enable it by checking the enabled box. The second box there is required by the standard, but I don't recommend that you enable it. What it theoretically does is allows a UPnP user to disable the external interface, probably not something you want to delegate to your users. And then finally, the last one is also kind of interesting. It's called Show Dummy Rule, which enables a workaround for some broken implementations. Whatever that means, I have no idea, but that's also purely optional. So with UPnP, you simply enable it, and then you set the interfaces where UPnP is going to run. All it needs to know is which interfaces are local area network interfaces and which ones are external interfaces. So once you set up UPnP, then anytime you have a host on the network that utilizes UPnP, it will dynamically create NAT rules for those particular hosts. So here's a apartment complex that has 800 bedrooms, I guess almost all students, and once we turn on UPnP, we get 2600 dynamic NAT rules created in our router. The number of calls about the silly message about, what do they call it? What kind of NAT? Yeah, those went away by about 90%, but we still get, an occasional call once or twice a week about that. So I'm not sure that it's 100% effective, but it certainly has reduced the number of calls about that. All right, next is the Let It Flow for 400. I'm speaking specifically about IP flows. Tom talked about IP flows a little bit yesterday. I just want to hit it one more time because I feel like it's often ignored. But IP flows, or IP traffic flow as it's known in Router OS, is a great way for you to get statistical information about what's going on your network, and especially what's flowing through your router. Most of that time, that information may not be totally relevant or important to you, but as they say, when the fit hits the shan, it's time to have a place to look and get that kind of information. Some of you may not catch that joke, but that's okay. All right, so in MikroTik, it's not called net flows, it's called IP traffic flow, and it's a system that provides statistical information about the packets going through the router. And besides network monitoring and accounting, it's a way to identify problems that are occurring or problems that have occurred in the past. So IP traffic flow by itself is not sufficient to actually get meaningful information. We have to have a place to send that, and we call that the target. So when you set up IP traffic flow, you first of all enable it, and you run it on the interfaces where you want to collect your information. Secondly, you set a new target flow or a new traffic flow target. So in this case, it's 10001, which is my laptop, and whatever port the particular server program is running on. There's several NetFlow programs out there. Tom named quite a few more than I'm familiar with. I know NTOP and I know the Manage Engine one, both of which have free versions. And it will give you information that looks about like this. So this is just one of the graphs, and as Tom mentioned yesterday, the big piece of the pie is most likely your victim or your culprit, and gives you a very graphical view of everything that's happening on your router. You can view it and sort it a number of different ways by source IP, destination IP, source port, destination port, protocol, country, and there's a million ways to sort it and view the data. So again, it's very useful information because it lets you see in a bird's eye view what's going on in your network. What is this called? The program that I use for it? That one's the Manage Engine. I think they call it Manage Engine Flows or something like that. Manage Engine is the company that makes it. So the way you create the NetFlow or NTOP or whatever server in your network is to simply set it up on an extra interface of your router, and then any traffic that's flowing through the router will get sent to that target. All right, and finally, Config Me Baby. This is going to be the free category. You don't get anything for it, but you also don't get charged for it. And what I'm talking about is my site, MikroTikConfig.com. So I introduced this in 2013 at the St. Louis MUM, and it was really a reaction to the number of calls that we have from different people asking us to do configurations for them. And I felt bad charging people for something that I had scripted and we're simply pasting in a script, so I decided, hey, what's better than giving a guy a fish, and that's teaching him to fish himself. So that's what we tried to do. Our first version was completely Java-based. It had limited functionality. It was a bear to maintain, so we decided to switch to a web version, and we released that in 2014 at the Pittsburgh MUM. Originally, we had capacity to create firewalls, to create QoS, and we added country-based address lists that we were pulling from a MySQL database. And so this year we've added PCC-based load balancing for either 2 or 3 different WAN connections. And so the way the configurator works is you log into MikroTikConfig.com. Don't everybody hit it at once and break my little web server. But from MikroTikConfig.com, you pick what type of configuration you want to create. And I'll do a demo here in a moment and show you how that's done. Once you're there, you simply fill in a couple of blanks, and these blanks are peculiar to your particular network. In this case, I'm showing the load balance configuration for 2 WAN connections, and the information that you'll put in consists of any directly connected networks, so that would be any DAC routes that you have in your routing table, and you also put in any masqueraded networks. Typically, those are going to be the ones on the inside of your local area network. Once you have that information put in, you hit the submit button. It's going to allow you to download a text file. That text file is a complete configuration script for this function on your router. So I'll do a quick demo for you. I always kind of like Greg, shy against demos because you never know what bad thing is going to happen, but we'll try it anyway. So this is the MikroTikConfig.com site. And our projector is not real great resolution, as I see, but on the left-hand side is a set of buttons. First of all is the firewall config tool, and this is done in a couple of steps. You can jump down to a later part of the configuration script if you like, go directly to it, but this is one that I use fairly often, and I update it regularly anytime they send out an update from the source where we're getting these address lists. But basically, it's an address list section, and in this list, you can go in and pick any countries that you want to create an address list for. And you check the countries, and you hit Generate Address List. Once you do, it's going to download a text file, and that text file is simply a list of commands that are going to add those IP blocks into an address list. And then if you write an address list rule and you reference the address list called country IP blocks, then you can perform some action on those particular sets of addresses. So it's pretty simple to use. I typically use it kind of in a reverse fashion, and I allow the countries that I'm interested in allowing, and then just write a drop rule to drop everything else. The second part of the firewall config, it allows you just to create a very simplistic firewall with the minimal number of rules. The only thing you have to specify is the name of the local area network interface, this interface here. So assuming you have everyone on a bridge interface, you put in bridge 1. Once again, you hit generate masquerading firewall. It's going to download a text file, and in that text file are all the commands that you need for a very basic firewall. You can, at this point, either copy that to your clipboard and paste it into a terminal window, or you can use the import command to import it in. And if you forget about all that, down at the bottom of the screen are a number of tutorials that I created on YouTube that show you how to import and how to use the different firewall tools. Introduced previously was also the QoS config tool. Same thing, it's simply a matter of filling out the form. It allows you to put in things like per user rate limits, which will create simple queues, and then to identify some of your high priority traffic like voice over IP or anything that you've set the DSCP bit on. Also, you can identify traffic based upon the IP address of any voice over IP gateways, or you can do it by port. And then down below that section is all the different services that we might want to prioritize for. And we can add to these as well, or we can make changes to it. So for instance, if we're running Telnet as priority 2, we want it to be priority 1, we can just make that change. Or if you want to insert a line and create your own service, name it whatever you want to, you can do that as well. Once you're done setting up your services or just accepting the ones that are there, you click download script. Once you load that script into your router, either through a paste or through an import, you're going to get a set of queue rules like this for each of the 8 different priorities in the upload direction and download direction. If you specified a per user rate limit, you'll get simple queues, and you also get a number of mangle rules here in your mangle list. So it does it all for you, pretty simplistic, and it's pretty hard to mess it up. And then the last thing is the load balance, which we added this year. And again, it works the same way. It wants to know any directly connected networks, so those would be any DAC routes in your routing table. You add those in. You put in any masqueraded networks, and then you fill in a few more pieces of information. Once you're done, you hit Generate Load Balancer, and now you're going to have a PCC-based load balancer that will balance between 2 WAN connections based upon source-destination address pairs. So every new source address pair that hits your connection tracking table will result in a change of gateways, and that will stay consistent even through connection tracking flushes. And we also added it for 3 WAN connections because the setup's a little bit different. And so far no one's asked for 4 or 5 or whatever, but you could simply copy this throughout those different scenarios. So that's all I have for you. Just about out of time. We do have time for some questions. Some of it I went through a little fast, so if you've got any questions, I'll be glad to answer.
In your example of hairpinning, and you're using a dynamic IP, do you marry those 2 examples together that you explained?
The Hairpin NAT only has to know the RFC 1918 addresses in my example. So all you would have to say is anything coming from the local area network going to the host, we're going to masquerade that. So in that case, the host address would actually be the private address of the host.
Can you put up your contact page?
Sure. It's actually the next slide. Yes, sir.
On the UPnP,
Would you enable that on just the front end, the public facing router, or would you put that through every router inside?
Yeah, no, you only need it on the router that's doing the masquerade, so the one that's at the edge of your network. Yes, sir. Oh, I'm sure there's a ton of them, but you know, as far as security is concerned, it really depends on what kind of security you're concerned about. Is it going to make someone be able to hack your router? No, because it's not going to bypass any firewall rules. And the dynamic rules that are created are always going to be for hosts that are wanting to use the UPnP service. Does it create a possible security issue for customers? I suspect probably. I've not really sat and looked at that particular application, but yeah, anytime we allow something inbound, we certainly open ourselves up for some kind of an attack. Anybody else? Yes, sir.
Your load balancing example, would that work with a static and dynamic?
Yes and no. If you look down at the bottom, it's really set up to be used for a static address. Right, for two statics. But if you look down at the bottom of the script, there is a scheduler built in there that is disabled by default. And there's also a script that Andrew from, where's Andrew from? New Zealand? Huh? Andrew Cox is from Australia, yeah. That he wrote for me, and that script would allow you to use a dynamic address on the WAN. You just need to uncomment it and make sure that it gets pasted in as well. So what it does is every few minutes it looks to see what the IPs are and it adjusts the rules accordingly. But all of that is disabled in the script by default so that it won't cause problems, but with a little digging you can figure out how to make it work. Anybody else? All right, thanks a lot. See you guys around.